Measurement, EMF, and terminal voltage. Voltmeter. Voltage is measured with a voltmeter. That makes sense. Voltmeters are connected in parallel with whatever you're measuring. Okay, here's the voltmeter, and you're measuring the voltage across this resistor. They measure the difference in potential between 2 points. Since circuits in parallel have the same voltage and a voltmeter has very high resistance, very little current passes through it. This means that it has little effect on the circuit, but whatever this reads, the voltmeter, that will be the voltage across that resistor. Current is measured using an ammeter. Okay, current's measured in amps, so it's measured using an ammeter. Ammeters are placed in series with the circuit. In order not to interfere with the current, the ammeter has a very low resistance, but the current going through the ammeter is the same as going through this resistor. Although there are separate items to measure current and voltage, there are devices that can measure both, of course one at a time. These devices are called multimeters. They can also measure resistance. And you can click here for a nice simulation on circuits, and it shows you where to put the voltmeters and ammeters. A battery is a source of voltage and resistance. Here's our battery here. Here's our plus terminal. Here's the negative terminal. Each battery has a source of electromotive force, right here, the voltage, and an internal resistance. The internal resistance is modeled with a virtual internal resistor. It is not a real resistor, but it just models the resistance inside the battery. Electromotive force, EMF, is the process that carries charge from low to high voltage. Another way to think about it is that EMF, right over here, is the voltage you measure when no resistance is connected to the circuit. So you don't have anything there, and if you put a voltmeter here, since no current is flowing, you will measure the EMF. Terminal voltage, or V sub T, is the voltage measured when a voltmeter is connected across the terminals of the battery. If there is no circuit attached, no current flows, and the measurement will equal the EMF. If, however, a circuit is attached, the internal resistance will result in a voltage drop and a smaller terminal voltage. We can then say that the terminal voltage, Vt, is equal to EMF minus IR, is a maximum when there is no current flowing, right? If there's no current, Vt would just equal the max voltage or the max EMF. When solving for equivalent resistance in a circuit, the internal resistance of the battery, this guy right here, is considered a series resistor, right? Because all the charges flow like that. So R equivalent will equal R internal plus R external. And R internal is represented by little r there.